All right, hello everyone. Welcome again to This Week in SU2. So we're gonna do another week. We have a group of the developers with us this time. I'll start from this side. We have Santiago, David, I'm Tommy Kahneman, we have Francisco, and Andrew. So we're gonna jump into some questions again. Oh, and our control guy, Anakin. Sorry, he's always hiding off on the side there, so I forget about him, apologies. We're gonna do what we've been doing for the past couple weeks. So we're gonna have some of your questions that you guys have posted on the forum. We're going to go through those, so thanks for posting more questions and getting involved. It's great. But first, we have something really pretty exciting that we want to talk about that we're going to premiere for you today. So last week we talked about open source, why it's important for the code to be open source, and what the benefits are of that. And but a lot of folks are probably now wondering, well, how do I get involved? What does being open source mean for me? What benefit do I get? So the idea is that you can become a developer. You can become a developer of SU2. And so today we want to show off a brand new developer page we've created for you guys that we're really kind of excited about. We'll probably push it sometime next week. But today we want to walk through it and maybe tell you guys a little more detail about how you can start getting involved. So I'm going to jump over to the screen and show you guys the website. Okay, so here's our normal SU2 webpage. But what we have hidden here that you can't see yet is a new tab called Develop that's going to show up sometime next week. And this is our new developer page. So the first thing that you'll notice here at the top is a comment about joining the team. And the first thing we want folks that are going to get involved in the code to do is join our developer email list. And the idea here is that we want one big email list that everybody can use to sort of communicate and discuss developments in SU2. And the idea is that we'll have a clear channel of communication between each other. We can discuss certain things that have to do with again, developments and not necessarily feature requests feature requests are good, but usability. So Andrew, I think you wanted to make a comment here.
Yeah, so I mean, ideally with the developers list, if you have a problem with implementing a new solver or in some part of the actual structure of the code, you would email the developers list. And if you have a problem with what you're running or a config file, anything like that, then you should post to the forum and use the forum that we've been cultivating over time and has a pretty active user group. So users kind of, when you're trying to get your own results, then you want to use the forum for almost everything, because that can allow the most number of people to learn from previous errors that have occurred, and then we can identify potential problems that are located on the forum, and then create issues on GitHub to correct using the developers list.
Yeah, so we'd like to hear from folks out there who are working on new things and developing things in the code on the list, and you never know, there might be other people who are working on the same thing, so there's a chance to find some collaboration. So that's really the spirit of that email list. Another note we have here is really starting to receive recognition for contributions, and to that effect, another feature we're unveiling is a list of the current teams we know that are developing SU2.
We are preparing a list of the teams that we know that they are using SU2, and each team is going to have their own small web page where they will describe what they are doing. We are working on this, and we will contact the team. So if you are a team that is actively developing SU2, just contact us, and we will add you to the list.
Yeah, we really want to make sure that folks out there who are working on the code are kind of recognized for what they're working on, and we can have links to your pages and bios and make sure that everybody knows what's going on. And that can also help collaboration as well. We have a note here about our exciting developer meetings that we're holding on YouTube, so if you're watching this, you already know about that. And then we have a bunch of information about how to get going on GitHub. So GitHub is kind of the center of the development universe for SU2. So when you want to start developing, the first thing you want to do is get on there, make a free account, probably fork the code and start getting involved. And we have a very particular way we want people to do that when they're going to start developing the code in terms of how you deal with branches.
Yeah, so we switched this a couple weeks back. We want to exclusively, we created a new branch called Develop, where we want to use it exclusively to develop, and we will have the master branch, which we used to develop on, but now it will be used as for stable releases. So we will encourage you to, anytime you have a new thing to add to the code, put in a pull request for the develop branch, and we'll take a look at it.
Yeah, it takes some time to review the implementation, but in a week or so we will accept the changes.
Yeah. And another important thing is, since now develop is the branch everybody's working on, and master is the stable release. If you just want to use the code, you can trust that you can get on GitHub, clone the master copy, and you have a version that is tested against the regressions, and it's working, and it's everything is all good. The development branch is always the one that's being tested by the regression scripts, the test cases. So we'll know right away if something gets committed to that branch that throws off the regression tests. This gets back to what we were talking about last week about how we verify that the code is working, and we have a lot of checks in place. So the develop branch is always being tested. So we also have ways of contributing the code. So what we really encourage folks to do is, after you make a GitHub account, is just go ahead and fork the code into your local account and start working on SU2. And then once you have features that you want to share and get back into the main repository, you can submit pull requests to do so. And we'll go ahead and review those, and maybe we'll make some suggestions and we'll comment on it. But then the hope is that we'll pull it in, and in this way everybody gets to sort of benefit from the things that the community is working on. So we really think that that's an important piece of the puzzle. Lastly, and we're going to keep rolling this out, this page is meant to grow. We have developer materials at the bottom. A couple of these are still in processing, but the first thing you'll notice here is we have the material from the SU2 Pointwise joint workshop, and we'll keep adding to that as we go. We're going to keep adding more materials about how to develop the code, and more specifics about getting involved in the source code, and more tutorials and hands-on material for that. So you'll see that coming too.
It was not clear for me if that should be in training or in develop. Have you think about that? So at least the workshop. I don't know. What do you think?
My opinion on this was, if there's going to be something that gets down to the level of the source code, then it's how to modify the source code, then it feels like a developer.
So second day of the workshop should be there, but first day is
maybe the first day should be in training, but we can talk more about this. What do you guys think?
Well, if either way where it goes, one should have a link to the other.
Yeah.
Yeah, it's like if you're in training, you want more advanced stuff, it'll point you to the developers.
Yeah. I think that we need to move on, but
Okay.
I'm not sure if we'll start to develop. We need to add some kind of a wiki or something that the people can active modify.
Yeah, if there are any suggestions out there, I guess this is a good chance to say if you want to post something on the forum, or I guess this could be a suitable topic for the development email list. If you guys have feedback on the kind of stuff you want to see on a developer's page, or how you want to interface with the code, or through GitHub.
Or you want to contribute, because we know that there are some people who have created their own scheme of the entire code, and they have very nice ideas.
So that's a little preview. I hope you guys are excited about getting this page next week sometime, hopefully, and we'll keep working on it, and we'll let you know as soon as it's available.
Can I have one more thing?
Yeah, please.
So in terms of the branching, as I said, the develop branch gets changed quite often because we have a lot of developers. So if you're going to create a big change, I might just encourage you to create your own branch. So a change will take you some time to implement, let's say over a week or maybe even a month, because that way, and then you will merge that into develop. Otherwise, develop will be changing too fast for you to be able to do your own changes. So.
That's a great point. The typical model we use here in the lab of folks that are developing is, if you're going to be working on a feature maybe for your thesis, for instance, that's going to take a long time, you might just make a branch and keep updating from the master into your local branch, like Santiago's saying, and then once you're finished, I mean, this could be years. Your branch could be, you can push it back into the master, or the develop, and then the master. So.
Yeah, I mean, I think you want to update from the developer, at least in our lab, we want to update from the developer list. Master is only going to be updated a couple of times a year whenever we have a release. So.
Yeah. Okay, any other thoughts on that, guys?
I think we need to move on.
Okay, we better get going into questions. All right, so same format here. These are questions we pulled right off the SU2 forum, and we're going to kind of take turns discussing answers to some of your problems. So let's start with the first one. This comes from Saitasia. I am getting an error message. Please remove the line boundary conditions from the mesh while using the TNE2 Euler solver. My test case is a semicircular geometry, which is rotated by 3 degrees in the phi direction, in the angular direction. And I am setting the bottom axis as a symmetry boundary, but this is giving me the error. What should be done? Francisco, do you have any thoughts on this one?
Yeah, here I think we have two different questions, so I'm gonna use the computer. So the first question is related with okay, yeah. So the first question is related with the grid that we have, and so this kind of message that says please remove the line boundary condition from the mesh means that you need to go to your SU2 file and just remove. You should have a boundary that is composed by line, just by edges, in a 3D problem. So just go to that part of the code of the SU2 file and remove that boundary, and do not forget to reduce the number of boundaries, the total number of boundaries that you have in your mesh. So that's gonna solve that small problem with the grid.
Francisco, can I jump in? This is a pretty common one. You'll see these degenerate axes a lot of times when you're using structured meshes for bodies of revolution, or like Sears hack bodies, or bodies. These types of things often have a degenerate axis along the bottom there. So that's pretty typical. Some can handle that. Luckily for us, if you just remove that and treat those elements there as wedges or prisms, you'll be fine.
And the second question is related with the TNE2 solver. So I should say that we have worked a lot in this two temperature Navier-Stokes solver, and we have validated the solver, and it's working pretty well. The only point is that the version that is working is, as we said before, is in a particular branch that is adjoint TNE2. So if you go to GitHub, do we have GitHub?
Yeah, it's in the.
Oh, perfect. So if you go to GitHub and then we go to SU2 and then you go to branches, there must be a branch called, let me see here, active, this one, feature adjoint TNE2. This is the branch in which we have the most updated and validated version of this solver. If you have any question about this solver, my recommendation is to directly contact the developer, which is Sean Copeland. And that's all that I want to say about this.
Okay, so let's jump into the next question. We have another one from Suman. It says, the dynamic mesh moving wall that is offered by SU2, does it solve the problem by assigning the mesh points on the boundary with a specified speed with which we want the wall to move, or does it actually deform the mesh? There's a second part, but why don't we talk about that first one, that first part first. Santiago?
Sure. So the dynamic mesh, the moving wall problem, what it does is it assigns a grid velocity. So you're not actually deforming the mesh, you're just specifying a velocity which will be used then when you compute the flat. That is the answer to that part.
Yeah, it's a very typical kind of moving wall boundary condition that you might use for like the classic lid-driven cavity problem, or a spinning cylinder in laminar flow, something like that, where you're not actually moving the grid, you're just imposing a velocity. So, and then the second part is, if it actually deforms the grid, can someone please tell me which mesh deformation strategy is used, like the spring analogy or blending formulation? And also, it would be helpful if somebody can mention the CPP file, which code within it. So Santiago, other thoughts on that?
Yeah, so as we said, like, particular moving wall problem doesn't deform the mesh, but we have a lot of other problems that for which you will want to deform the grid, so I'll show you where that is in the CPP file. So we have problems that, for optimization problems, where you probably will use a deforming mesh. If you have, we did this during the workshop, if you have pitching airfoils or some sort of motion, that you could use the deforming options as well. So these are in, if you go into, again, let's just start from the beginning, SU2 CFD, we'll have the main iteration. So we begin the solver and then we'll jump into mean flow iteration. which is an iteration structure. At the beginning of iteration structure, CPP, if we have any kind of mesh motion, or even if the mesh is not moving, we're specifying grid velocity, it will be inside set grid movement. This is still in iteration structure, it's just towards the bottom of the file. And so here we can see, like, we have different cases. So for the case of moving wall, I actually go into it and see what it's doing. So basically, what you want to see is at the end, it's setting the grid velocities as for each node. So we're not deforming the grid; it's just setting the grid velocity. So moving wall, and now for a case where it's deforming, let's go in deforming here. So it could deform due to different movements. Let's say it's let's go to, so it could either be plunging, pitching, or something else. And once you do the movement, then you're going to call set volume deformation. And these are inside the grid movement structure CPP. And in here, you're solving so we used to do the spring analogy, or like torsional spring, but we've moved away from that, and now we solve a linear elasticity problem, or it could be a nonlinear elasticity problem. And the parameters for those are specified in the config. I'll show you those in a minute. But basically, in here, we're solving the linear elasticity problem. So you can take a look at here if you actually see how that problem is being solved. But the parameters you'll specify for that are in the config, and so that'll be grid deformation parameters. So you just want to, similar to the main solver, you just specify how many steps you want to use, what tolerance you have, and this is important. The question asked how to keep like boundary layer elements maintain their shape. Is it something like that?
Maintain orthogonality. Yeah, this is exactly why we went to the linear elasticity formulation. Yeah.
And in order to do this, like what you do is, because those are small elements, you want them to have a higher stiffness. So you can specify stiffness here, for instance, inverse volume, because they have a small volume or area, they'll have a much higher stiffness. So that way we can ensure that we're going to maintain the grid quality. Do you want to add anything on that, or?
No, that's good.
That's perfect.
That's good. Yeah, let's keep moving.
Thanks.
Okay, so our third question is from V. They ask, I would like to simulate a shock tube problem for which I need to set two different initial conditions. And then there are some details about the tube. It's 800 units long, and the first half needs to be a certain initial condition, and the second half needs to be the second. They're trying to set it in the set initial condition subroutine, but it is not working, and it's not starting the simulation. So Francisco, maybe do you want to share some thoughts about this?
Yeah, so maybe we can first of all be sure that the grid is the grid that he needs. So if you want to say something about the kind of grid.
Yeah, so for a shock tube grid, usually what you do if you're outside of SU2, when you're just doing like a quick MATLAB program or some other programming language, you'll choose to do something that's 1D, because what you're interested on is in the flow that's moving in the direction of the shock tube more than what you will be in the direction radial to the shock tube. For the case of SU2, you can treat it as a 2D problem by creating a grid that will be one cell height and then many cells into the length direction, meaning that you will have one cell that will represent the diameter of your shock tube, and then you'll have as many cells as you want representing the length that your shock tube has. And in that 1D problem, and treat it as a 2D problem.
Do you need a resolution on the?
So the resolution
at the boundary, or is that necessary?
You will need high resolution where you're expecting the shock to be, but usually in a shock tube, your shock will be moving. Okay. So you will want to have enough resolution to capture that shock, because if you have cells that are too big, your shock will start getting spread and become thicker and thicker. So
yeah, we typically use this to validate the convective scheme, and then there is a very well-known problem, is the subtube problem, and we use this we have done this in the past several times. So you are in the right subroutine, set initial conditions, completely agree. And looking at your source code, I think that the only thing that is missing, you must keep in mind all these set initial condition at every iteration. So you need to add some kind of if statement where it says that if you are in external iteration 0, then apply the initial condition. If not, then you will not apply again. Maybe that's the reason nothing is happening. I don't know if you want to say something about the source code, but it seems okay for me. Be careful because we work with the conservative variable, so be sure that you, in your solution, you have density, velocity, and density energy. And that's all. Let us know if.
But yeah, I guess the key is, make sure you're setting it at the beginning and check how often this is called. So this set initial.
Yeah, I have the impression that you need to add some kind of if statement to be sure that you call this only in the first iteration.
And I believe there's other set initial conditions that actually have an if this is iteration
right.
0, do that. So in here, like you'll probably see an example of that being done.
Yeah, so what's the reason for calling a routine called set initial condition multiple times?
This routine is acted a little bit like a catch-all for kind of special cases. So I know that Francisco, for instance, set conditions around nacelle boundary conditions, when you need subsonic flow. I've used it to restart unsteady problems because you kind of have to make sure you're reading in 2 restarts if it's second order dual time stepping. It's a little bit of a catch-all routine.
Yeah,
so.
but it's a good point. Probably we need to update this. We will create an issue and we will fix this.
Yeah. Good philosophical question.
Okay. I think for the unsteady problems, it gets called every major iteration.
Yeah.
Oh, that could be also.
So it just reads the previous 2 or previous 1, depending if you're using a first order or second order time stepping, and then it.
I thought it was
uses
just the external, because we have external and internal, and I
Yeah.
thought if the external was 0, it only got called. But
Yeah.
let's
Okay.
check this.
Yeah.
Let's double check.
Good point. Thank you.
Good question. Yeah, I think you're on the right track. So, okay, let's go to the next one. We have a question from Steven. He asks, has the DLR F6 test case from version 3.0 been relocated in the repository? So, Andrew, do you have any thoughts on this one?
Yes. The DLR F6 is a transonic aircraft model, and actually what we've kind of decided over the last couple of months is that we're going to move away from the DLR F6 and move to the NASA Common Reference model. So we feel like this is a good idea because the Common Reference model has been used in the AIAA drag prediction workshops and is more indicative of what transonic aircraft actually look like, because it's very similar to the Boeing 777 aircraft, and there's wind tunnel data available to be able to match our results. And we're in the middle right now of validating SU2 with the data from the wind tunnel so that we can hopefully match these conditions in the near future. At the same time, we are not going to put these meshes up on to GitHub in the test cases because these meshes are quite large. So we are happy to communicate with people who want to run these meshes, but at the same time, you're going to have to go to the drag prediction workshop homepages and pull down those meshes yourself.
So we can share the config file, but the meshes are.
The meshes are large, but they're available in CGNS format. We've put in a little bit of work lately to make sure they're all running, or most of them are running in SU2. So if you get the unstructured meshes, you'll be able to run those. So, yeah, to piggyback off Andrew, we're using the CRM now for a few different projects. So it's something we're kind of actively working on for scalability studies, fluid structure interaction problems, stability and problems. Design problems. We're actually using the CRM for quite a bit. So if you're interested and you want to share files or talk a little more about the CRM, we're certainly open to that. So.
But what if he wants access to DLR F6? Is that still available? Can you go to an old?
Probably in the drag prediction workshop in the first.
But was this ever available as a test case?
Yeah, it was available. At least the Euler, I think,
Yeah.
but never stock.
We have a grid. The problem is, the biggest problem is we can't put too many files on the GitHub test case repository, just their file size limits. So that's probably the biggest issue. I think we tried to keep some of the larger meshes out when we put everything on GitHub, but these meshes are available, and again, maybe we could share config files if
Yeah.
this is something that folks are really interested in doing. So.
Yeah, maybe in the test case repository we can keep config files, but then for these large meshes, because we only have a finite amount of space, we can give pointers to where you can go download a mesh.
Yeah,
to
that's a
use.
good idea. I think
Put a comment
maybe
in
we
But,
can
yeah,
make a comment with
I mean, at the
the-
same time, people should realize that these are not necessarily going to be part of the regression tests either,
Yes.
just because they take too long.
Okay.
When you want to-
Yeah, and then with the last few minutes, we have one more question from Amon. I have followed the installation guidance, but I still can't run the SU2 solver for the kind of the quick start tutorial, and I'm having trouble with the executables and configuration file. So I think we'll just take these last couple minutes, and I think it's a good chance just to go back to the beginning. We have a lot of new users who are just getting started with running things in the terminal or running executables, or maybe we don't have a GUI, so this is something that's maybe a little bit new for folks. So I thought it'd be good just to walk through the beginning, just go back, show you guys the website, show you where you can get the code, and do just a quick test to show you how to run the executable real quick. So I'm going to jump over to the screen.
And one thing, I like these questions that are not, like, I would encourage other people, like, to just respond on the forum, because people who have started using SU2 have likely figured out how to get past this first step. So I would just encourage you guys out there to, anytime there's a question you're able to actually answer, just go ahead and answer.
Yeah, that's a good idea. Okay, so I'm going to switch over and we'll talk a little bit about just a reminder of how to get started with the code. So the first thing is to go back to our main web page. So again, su2.stanford.edu, here's our home. There are a number of tabs up top, so without going into too much detail on all of them, Guides right now holds our user documentation. This is all hosted through Confluence, so it's a wiki-style documentation site. There are a lot of tutorials, a lot of information on how to get different files ready, meshes, input and output files, all sorts of things that you could want. The forum here, this links you straight to the CFD Online forum that you guys probably are aware of, where you've been posting these questions, so that's great. We have a training tab, which is where we now have kind of materials, so how to use the code, how to get started, a lot of presentations and some videos are linked there. Right now we have news, but this is going to be replaced soon with our develop page that we showed you and contact. So if you want to get started with the code, there are a number of ways, and again, GitHub is really the center of the universe again for SU2, but if you wanted, you can go to our download page, you can come here, you can scroll down, and this is going to offer the opportunity to download just the binaries, so a stable release. Right now we have version 3.2 linked here, and some other old executables. So you can always come here and just grab the binaries straight off of our own page, or you can roll down and have some instructions for how to get them to GitHub, and also how to get access to the test case suite. So we more so encourage folks to try to do things through GitHub, but we do also like hearing from you guys and like having you register and let us know that you're using the code. So registering here and downloading the code is a great idea too. Okay, with that, I want to jump back over to GitHub. So let's assume you want to come over here and you want to get the code right off of GitHub and get started. And maybe you still just want binaries though. So let's do a quick example of that. You could come to our main page on GitHub, so GitHub/SU2 code. Go to our SU2 repository. And along the top, you're going to see a number of things. So in here, there are the files, and there's a README at the bottom. But you have this tab that has commits, branches, releases, and contributors. So if you wanted to grab the most recent release, you could just click here on 17 releases, and you're going to find a whole page of our recent releases that are tagged, version 3 point whatever. If we go to the most recent, it's 3.2.2, and you can even just click right here. I think in your post you said you were working on a Mac, so I know my laptop is on Maverick, so I can go ahead and just click this. And that's going to download a tarball with the binary files in it. So if I were to come over to my desktop, you'd see I've already downloaded this and have it here, but I've got the binaries on my desktop. And if I go to a terminal, so I want to just run this quick start tutorial. Again, you'll need a terminal for this, so luckily on Mac this comes built in. You're just going to pop that terminal open. On my desktop, I have those files. I've actually already decompressed this using the tar utility. If I go into bin, you're going to find our precompiled executables along with the Python scripts that we ship with the code. So inside this bin directory, you can go into the quick start, and very easily you can call the executable from the command line that's in the directory above with the config file you need. So again, the format is the binary executable name followed by file name, and run that. And so that's how you would go and grab the file straight off of GitHub and get started running kind of the quick start, a basic quick start. But again, we encourage you to download the whole source, start playing around with these things on GitHub, and once you get a little more comfortable with how to run the code and working with the binaries, we really encourage folks to kind of interface through GitHub and get started.
Yeah, I guess I'll just add to make sure the configuration file is in the same directory, it's in the same folder. That could be part of the problem.
Yeah, and remember that this kind of binary is serial and without tech I/O, so the most basic version of the code.
Yeah, and we showed, I think, a little while ago, we have a bunch of Python scripts that have a lot more flexibility that can automate all this stuff for you. But if you're just looking to get started running the quick start, that's the quick example. So, okay, I think we'll call it a day there. We've answered your questions. If you guys have feedback, this style of format for these meetings, or if you have more questions you want to ask or more topics you want to talk about, please put them on the forum. We love hearing from you guys. So, I think we'll call it a day there. You guys have anything else?
Thank you very much.
Nope. Okay, thanks for joining.